Okay, this is the video solutions for properties of exponents 2, and this time we're going to use a division property when we have two exponentials with the same base. We see it in class. We have the property of b to the n over b to the m. This is division with two exponentials, the same base called b in each case, and that's equal to b to the n minus m. In other words, we do take the top power and we subtract it with the bottom power. So let me do it this way. Notice that we have this top power, that's on the left, and we subtract the powers, bottom power, and that's on the right. So you're going to take n minus m and you're going to keep the base. And this is the property that we're going to use when we divide two exponentials with the same base. Let's recall, whenever you see a number, you can write it as an exponential. Make sure the base is 1. So this is really 3 to the first power. We could write it a little higher because it's raised. This is 3 to the first power. So how we'd use this property here would be keep your base 3, subtract 4 with 1, and I get 3 to the third power, which again, if you guys recall, that's 3 times 3 times 3. The value here is going to be 27. This is what we'll be doing when we subtract exponentials, or I should say divide exponentials with the same base. We subtract the powers and keep the base. So number 3 is 2 to the 4th over 2 squared. Again, same base, and we're dividing. This is 2 now to the 4 minus 2. Okay? Power 4, power 2, subtract those powers. 4 minus 2. We get 2 to the 4 minus 2 is 2. This is 2 times 2, better known as 4. We've evaluated. Number 5. 5 to the 4th power over 5 to the 3rd power. Same base, 5. Keep the base 5, subtract your powers. 4 minus 3, subtract. 5 to the first power, better known simply as 5. Number 7, 2 squared over 2 to the 4th. We have the same base. So we keep the base and we subtract the powers. Well, the base here is 2, and 2 minus 4 is negative 2. So this is a base to a negative power. So this is going to bring up another fact here. Okay, let's recall. If I have b to the minus m power, that's the same as saying 1 over b to the m power. In other words, you have a negative power here for your base. We can write this as 1 over b with a positive power now. And I'm going to highlight that positive power maybe in purple. This is my power m. It's now positive. So whenever you have this situation, like the situation we see here, where my power here is negative, well, I'm going to write this as 1 over 2 to the now positive 2, or the opposite of the negative 2. So I have negative m, and the opposite of a negative m is simply an m. The opposite of negative 2 is positive 2. Notice here, my power for 2 is positive. The exponential is in the denominator position. I know what 2 squared is, right? 2 times 2, this is 1 over 4. And we're done. So we're going to use this property as well. We discussed that in lecture Number 9, we have 4 to the third over 4 to the fourth. Notice, same base. Keep the base. Subtract your powers. 3 minus 4. Subtract. We get 4. 3 minus 4 is negative 1. Again, a negative power. I'm going to write it as 1 over 4 to the positive power now. That's opposite of a negative 1 is a positive 1. And yes, my base, or I should say my exponential, is in the denominator position. And 4 to the first power is simply 4. This answer is 1/4. Number 11. 3 to the fourth over 3/6. Same base again. 3, 3. Keep the base. Subtract your powers. 4 minus 6 will give us negative 2. That is a negative base. We're going to write this as 1 over 3 squared, where that base here now is positive. And 3 squared is 3 times 3. This is 1/9. Number 13. 5 squared over 5/5. Same base. Subtract the powers. 5, 5. That's my base. 2 minus 5 will give me negative 3. Again, a negative power. Write this as 1 over 5 to the positive power. That 3 is positive now. I know what 5/3 is. It's 5 times, or 5 to the third power. It's 5 times 5 times 5, which will give us 125. 1 over 125. That's number 13. Number 15. X to the fourth over x squared. X to the 4 minus 2. Notice again, same base, x and x. Here's that base x. 4 minus 2 will give us positive 2. X squared. And we're done. Number 17 is x to the fourth over x cubed. Well, keep your base, subtract the powers. Notice base x and base x are the same. We keep that base. 4 minus 3. 4 minus 3 we know is actually 1. This is x to the first power, or just simply x. X to the third power over x to the fourth power is x to the 3 minus 4. Same base. Keep the base. Subtract your powers. 3 minus 4 is negative 1. This is x to the negative 1 power. I'm going to write this as 1 over x to the positive 1 power. My power now here is positive. This is 1 over x. And you're done. X to the fourth over x to the sixth. This is x to the 4 minus 6. Base x, keep the base. They're the same base. 4 minus 6 here. We get x to the negative 2. The power is negative 2. 1 over x squared. That negative 2 power is now positive 2. And we're done. I want to point out something here. The instructions say write with positive powers. Now this is an absolute must here when we simplify. It's not enough to say your answer is x to the minus 2 power. It has to be 1 over x to the positive 2 power. And we discussed that, and that's what the instructions say. So that's what we have to do. Let's look at 23. X to the fourth, y. Over x squared y. Now let's look at some details here. Multiplication here, power 1, power 1. So we're going to use our property for dividing exponentials with the same base here. So I have a base x here and a base x here. That's going to give me x to the 4 minus 2, because I'm going to subtract these two powers right here, 4 minus 2. And don't forget, we have y and y here. So this is going to be y to the 1 minus 1 for the same reason we subtract the powers, 1 minus 1. When we do the arithmetic, we get x to the second power times y to the 0 power. Now let's remember, there's another fact that we're going to use, another property, that any base to the 0 power is the value 1. So I got to replace this here, y to the 0 power, with the number 1. We have x squared times 1, and anything times 1 is itself. This is simply x squared. That's number 23. X to the third power, y to the third power, over x to the fourth power, y to the second power for number 25. Again, keep the base x, subtract your powers. Keep the base y, subtract the powers. Same base, keep the base. Subtract 3 with 4, 3 minus 4. Base y, keep the base y. 3 minus 2 again. We get x to the negative 1, y to the positive 1. Now here, let me emphasize, I have a base with a negative power. I'm going to write this as 1 over x. Okay, now the power is positive. What that gives you is 1 over x times my y to the first power, which is just y. Now I'm going to ask you guys to recall something important. Recall how to multiply fractions. Triangle over square times happy face over a heart. And we're going to multiply. You always multiply horizontally across. Triangle times happy face over my square times my heart. This is how we multiply two fractions. We say multiply the numerators together and divide by the product of the denominators, and that's what you're looking at. And this is what we're going to use here, because this means I multiply here. Now take a look. 1 with y to get simply y, and then I multiply down here x with, if you want to think of a number 1 down there, and say x times 1, which is x, you can. The point is the denominator is x. This is actually y over x. So this is every gory detail here because you are multiplying really a whole number with a fraction, and you multiply horizontally across. You end up with y over x. (27) x cubed y to the 6. X to the 6 y squared. X to the 3 minus 6 y to the 6 minus 2. Same base. We subtract the powers. 3 minus 6. Here's your subtraction. Different base, they're both y. Keep the y. 6 minus 2. We get x to the negative 3, y to the 4th. Again, this becomes 1 over x cubed. So we'll end up with 1 over x cubed times y to the 4th. Again, y to the 4th over that x cubed. My x and y's look a little too fancy. Okay, and you might say, well, why is that? Because you're multiplying again two fractions, and you do that horizontally across. (29) 8x to the 4th y over 4x cubed y. Now this problem, we have to simplify, or simply divide. 8 divided by 4 is 2. So I'm going to have 2 here times. Now I deal with my x's, my division of my two exponentials with x. 4 minus 3. Don't forget to have 1's here. So this gives me my y to the 1 minus 1. Let's go back and take a look. Same base, and I'm dividing. Keep the base. Subtract 4 with 3. Y and y. Keep the base. 1 minus 1. We end up with 2 x to the 1st power, y to the 0 power. Now, y to the 0 power is the value 1. Final answer is simply 2x. (31) 27 x cubed y to the 5th over 3x squared y cubed. Again, perform your division. 27 divided by 3 is 9. Now, you're going to end up with 9x to the 3 minus 2, y to the 5 minus 3. The reason being is I'm dividing with the same base called x. There you go. Subtract the powers. 3 minus 2. Dividing with the same base called y. There it is. Subtract my powers. 9x to the 1st power, y to the 2nd power, or 9x y squared. And you're done. (33) 10xy over 2x to the 4th y squared. 10 divided by 2 is 5. Now, remember, if you don't have a power, by default, it's 1. So we have 5 x to the 1 minus 4 times y to the 1 minus 2. Because same base, keep the base. Subtract your powers, 1 minus 4. Same base, keep the base. Subtract the powers, 1 minus 2. 5x to the minus 3 power, y to the negative 1 power. So both of these here, this becomes 1 over x cubed, and this becomes 1 over y, because it's a base to a negative power. You get 5 times 1 over x cubed times 1 over y. And don't forget the whole number 5 we can write as 5 over 1. And when you multiply, it is simply straight across. Here's what you end up with. 5 over x cubed y. And you're done. Number 33. Here's 35. (20xy) over 5x squared, y squared. 20 divided by 5 is 4. Don't forget you have 1s for the powers here. You get 4 x to the 1 minus 2, y to the 1 minus 2. X, x, x. Y, and your y. Don't forget you have to take 1 minus 2 here, there it is, and 1 minus 2, here it is. You end up with 4x to the negative first power times y to the negative first power. Don't forget which each is. This is 1 over x, 1 over y. So again, I have 4 times 1 over x times 1 over y. We multiply straight across here. 4 over xy. And we're done. This was 35. 37. 2 to the 4th power over 2 to the negative 2 power. We use the same property. In this case again, notice we're dividing by two exponentials with the same base, so we're going to keep the base 2. We're still going to subtract my powers. This is 4 minus a minus 2. Because here's my 4. I take the top power and then I subtract, here's subtraction, the bottom power. And the bottom power happens to be a negative 2 this time. So we have to remember how to perform arithmetic with signed numbers. 4 minus a minus is actually 4 plus 2. So you get 2 to the 4 plus 2, which is 6. And we can evaluate this. 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 6. We get, let's remember, this is going to be 64. 4 times 2 is 8. 16, 32, 64. There you go. So be careful with this minus the minus business right here. It makes it a plus. And you're really going to add those powers, but that's the consequence of the property in your arithmetic. It's signed arithmetic now here. So this is 37. See how 39 goes. 5 to the negative 4 power over 5 to the 3rd power. And that becomes 5 to the negative 4 minus 3. Okay, let's take a look at what's going on here. Two exponentials, and it's division, so you keep your base 5. You're now going to subtract powers. You're going to take the top power, which is negative 4. Here it is. Then you can subtract, there you go, with the bottom power, which is 3. Here it is. Remember how to perform signed arithmetic, meaning -4 minus 3 is -7. And remember, we have to write this with a positive power, so that's 1 over 5 to the 7th power. Now, we're going to have to remember here what 5 to the 7th power is. So, we can kind of write this down and deduce this, I guess. Let's see, 5 times 5 we know is, let's see what this is. This is 1, 2, 3, 4, 5, 6, 7 of these. 5 times 5 is 25. Times another 5, that's 3, is 125. Okay, so 3 of these is 125. I want to point this out. Let's keep track. This number is 125. That means another 3, means if I multiply the other 3 here, 1, 2, 3, that's another 125. And then it's multiplied by the last one, which is 5. So let's kind of, if you go through the arithmetic, 125 times another 125 gives you 15,625. We have to multiply that by times another 5, by the way. We end up with the following answer. 1 over 78,125. Okay, perform that arithmetic. See what you get. $41. 2 to the minus 2 power over 2 to the minus 4 power. Keep the base 2, subtract your powers. So base 2, keep 2. -2, -2, minus a -4. So this is, again, is a minus situation. So this is 2, -2 plus 4. -2 plus 4 is 2. And again, 2 times 2 is the value what? 4. And you're done. $43. 4 cubed over 4 to the -4th power. Keep the 4, subtract your powers. Base 4, keep that base 4. 3 minus -4. 4 to the 3 plus 4, or 4 to the 7th power. Again, we have 4 times 4 times 4 times 4. 1, 2, 3, 4, 5, 6, and 7. So let's kind of multiply again the first 3, and then the next 3. And notice that 4 times 4 times 4, this is 64, times 64, times another 4. So we need to find out what 64 times 64 is. If you do your multiplication, you're going to get 4,096 multiplied by 4. Final answer is 16,384. $45. X to the 4th power over x to the minus 3 power. keep your base, subtract the powers. Let's double check. Same base, we're dividing, keep the base. 4 minus -3. Here's that -3. X to the 4 minus the minus makes that a plus. X to the 7th power. And you're done. (47) X to the -4th power over x to the 3rd power. Simply subtract the powers. Same base, keep the base. We're dividing, so -4 right here minus your 3. We get x to the -7th power, which is 1 over x to the +7th power. Rewrite this as a positive power, and you're done. 49. X to the -3 power over x to the -4. Keep your base, subtract the powers. Base x, keep that base, x. -3 minus a -4. Here's the -4. -3 plus 4. That's 1, or simply just an x. And that's 49. 51. X to the -4th power over x to the 6th power. Keep your base x, subtract your powers. Base x, keep the base x. -4, here you go, minus a +6. You get x to the -10th power, or 1 over x to the 10th power. Because -4 minus 6 is -10, and we have to write this with a positive power. 53. Let's write 53 a bit better. How's that? 53. X to the -3rd power, y to the 3rd power, over x to the 4th power, y to the -2 power. I want to remind you, we're multiplying. Just to remind you, I know you know. You apply the property, the division property, separately. X to the -3 minus 4, y to the 3 minus a -2. Okay? Let's go back and see why. Same base, we're dividing. Keep the base. Here's my power -3. Okay? You're going to subtract. You're going to subtract 4 now. There's the 4. This gives us x to the -7th power. Now for y, here's your y. Notice base y, same base. Keep the y. Okay, like in the first case, you kept the base x. There you go. You're now going to subtract the powers. This is 3. 3 minus a -2. There's a -2. Don't forget, minus a minus makes this a plus. So I get x to the -7th power times y to the 5th power. This has a negative power. We have to write it with a positive power. So that's 1 over x to the 7th. And we get 1 over x to the 7th times y to the 5th power, which gives you y to the 5th power over x to the 7th power. And that's 53. Okay? 53. (55) X to the -3rd power, y to the minus 6 over x to the 6 y squared. Keep the base, negative 3 minus 6 y to the negative 6 minus 2. Same base. Keep the base. Let's look at the powers. Negative 3 minus a 6. Here's your 6. Let's look at the y. Same base. Keep the base. Negative 6 right here, minus a 2. There you go. We end up with x to the negative 9th power, y to the negative 8th power. Don't forget, each of these can be written with a positive power if we put this over 1. And we're multiplying. And how you multiply two fractions is, we call that horizontally across, and then now 1 times 1 is 1. X to the 9th times y to the 8th is just that. X to the 9th, y to the 8th. And they're both over the number 1. And that brings us to 57. Where we have 8x to the 4th, y to the negative 1st power, over 4x cubed y. Don't forget a couple of things. That 8 divided by 4 is 2, and this y has the power 1. So I'm going to have 2x to the 4 minus 3 power, y to the negative 1 minus 1 power. Now let's see why. Let's go back and double check. Same base, x, and we're dividing, so we keep the base, x. 4, here's the 4, minus 3, here's your 3. Y over y. Keep the base y. Negative 1 minus positive 1. Let's see what you get. 2x to the 1st power, y to the negative 2 power. Now remember, this is 1 over y squared. Write it as a positive power. I get 2x times 1 over y squared, a whole number times a fraction. This is 2x over simply y squared. And that's 57. We have 27 x cubed y over 3 x squared y to the minus 1st power. 27 divided by 3 is 9 y to the 1st power. Now let's write down what we have. 9 x to the, this will be 3 minus 2, y to the 1 minus a negative 1. Because again, we keep the base as x, since we're dividing, and we subtract the powers. 3 minus that subtraction, the 2. Here we go. For your base y, y over y is y. 1 minus a negative 1. We get 9x to the 1st power, y to the 1 plus 1, because minus the minus makes that plus. You get 9x y squared. There you go for 59. (61) 10x to the minus 1st power, y to the minus 1st power, everything over 2x to the minus 4th power, y squared. 10 divided by 2 is 5. Let's use our properties now. 5x to the negative 1 minus a negative 4, y to the negative 1 minus a 2. Let's see why. Same base, and we're dividing. We keep the base x. Negative 1, here's my negative 1. Here's my minus, a negative 4. There you go. Y over y, keep the base y. And I have negative 1, minus a 2. There you go. So, 5x to the negative 1 plus 4. Y to the negative 3. Let's remember how to perform arithmetic with signed numbers. Negative 1 minus a minus is negative 1 plus 4. I get 5x to the third power, y to the minus 3 power. And don't forget, we have to write with positive powers. So that y to the minus 3 power becomes 1 over y to the third. And I have 5x cubed times 1 over y to the third. Let's write that nicer. And again, we multiply our fractions horizontal across, 5x cubed over y cubed. That's number 61. And finally, 63. 20x to the first power, y to the first power, over 5x to the minus 2 power, y to the minus 2 power. Okay. Don't forget, 20 divided by 5 is 4. Each power here is 1 for my base x, my base y, or my variable x, my variable y. By properties of exponents, 4x to the 1 minus a negative 2, y to the 1 minus a negative 2. Let's see why. Same base, we're dividing, keep the base. Let's look at the powers. 1, 1, minus a negative 2, negative 2. Base y, we're dividing, keep the base y. Let's look at the powers. 1, 1, minus negative 2, negative 2. 4x to the 1 minus a minus is 1 plus 2. 1 minus a minus is 1 plus 2. 4x to the third, y to the third, and we have positive exponents, or positive powers. We are done.